In this lesson, we're going to look at the basic structural components of an amino acid. The large image shows the 20 common amino acids. I've enlarged a section showing just 2 of them to give an example of their structures. In one, we have tyrosine, and in the other, we have aspartic acid. Notice there's some other information given with them. There's a 1-character abbreviation and a 3-character abbreviation. The information at the very bottom with the GAT has to do with the codons that code for this from RNA. You are not responsible for memorizing the names or structures of the amino acids. Let's look more closely at the basic structure of every amino acid and see what they share in common and what is different for each of them. So every amino acid has the same backbone, and that's what's drawn in the red box. In this case, we're showing the amino group, so NH3, this is an amino group. And on the right, we have the carboxylate ion. Sometimes we'll see the uncharged versions, and we'll look at another example of that in just a minute. But the key thing we want to look for the backbone is the amine group, a CH, and then the carboxylate or carboxylic acid group. So the NCC pattern is the backbone, and that's common for every single amino acid. The thing that's different for every amino acid is the side chain, which is represented here by an R in the green box. R is just the rest of the molecule, and that's where each amino acid differs from each other. And it's looking for the side chain and identifying its location will let you figure out what amino acid you're looking at. Now, when the molecule is drawn this way, it can be somewhat easier to see the side chain, but no, there are all different ways and orientations for this molecule to be drawn. Let's look at an example to identify the side chain on the given amino acid. The first thing we need to do is to determine what the backbone is. So we see our amine group, we see our CH, because remember there's an H attached there, it's just an implied hydrogen, and then we have our carboxylic acid group. So what we see is that this is the backbone of the amino acid. Therefore, everything else is the side chain, because every atom has to be part of the side chain or part of the backbone. Remember, there is a carbon there because it's a bend in the structure, so that's a carbon there with 2 hydrogens. And so what we see as our side chain is CH2SH. When we first looked at the basic structure of an amino acid, we saw the version on the left. And this is the version that's probably more commonly used as showing the 2 charged species. However, we can also draw it as the version on the right, and this shows the uncharged species. Basically, one of the hydrogens has moved from the amino group down to the carboxylate group so that we have neutral groups on both ends of the molecule. These are considered equivalent structures, so I would never ask you to decide which one is the best one because they're both fine. They're both acceptable and equivalent structures. We will see some examples where we have one charge but not the other, and those are not equivalent structures because remember, each of these molecules overall is neutrally charged. Think back to when we talked about functional groups and determine how we abbreviated carboxylic acid. So we use the abbreviation COOH to represent our carboxylic acid, C double bond O, OH. And when we look at COH, that was an alcohol. CHO was used for aldehyde. And then COOH is our carboxylic acid. And we'll be seeing that again as we start to look at amino acids. Because the name amino acid comes from the fact that it has an amine group and a carboxylic acid group.